Hello and welcome to lesson 6.1. Today we're going to look at ratios, rates, and unit rates, and this is the first video in a two-part series. So to start out with, we're going to look at what a ratio is. Now, a ratio is ultimately a comparison of two quantities, okay, and we typically do it with division, but there's a couple different ways that we can write a ratio. Okay, one would be to say something is, we'll say 10 to 15. So you could physically write it out like this. We could also write it out, and I'm sure you've seen it like this. And we read that as 10 to 15. Or we could show it straight up, just like as a fraction, and write it as 10 to 15, just like that. So these are three different ways that we can write a ratio. And again, it's just comparing two different quantities. So if we look at example one says, a survey asks students whether they had after-school jobs. Write each ratio as a fraction in simplest form. Okay, so over here, you can see that we have our data. 40 students have a job, 60 do not, and we have a total of 100. So if part A says we want to find the ratio of students with jobs to students without jobs. So we're looking at students with a job versus students without a job. So sometimes it might be easier to actually write it out. So the number of students with a job is 40. And the students who do not have a job is 60. Now I can go ahead and reduce 40/60ths down. I can write this as 4/6 or 2/3. So this right here tells me that I have, for every 2 students that have a job, I have 3 students that do not have a job. Now part B says that we want to find the ratio of students without jobs to all the students surveyed. So if I write this as a fraction, I have students without a job, and I'm comparing that to all the students surveyed. So the students without a job is again 60, and all that were surveyed is right here, so this would be 100, and 60 100ths is really 6/10, or I have 3/5. So one way that I could kind of summarize that is I could say for every 5 students surveyed, 3 of them did not have a job. Example 2 says it wants to look at the ratio of students with jobs to all the students surveyed. So the students with a job is 40, and we're going to again compare it to all students that were surveyed. So this becomes 4/10 or 2/5. So for every 5 students that were surveyed here, I have 2 that have a job. Next, I want to look at students without jobs to students with jobs. So it's kind of similar to part A that we did on example 1, but students without jobs is 60, and students with jobs is 40. So again, I can reduce this down to 6/4 or 3/2. And I can say for every 3 students that do not have a job, 2 students do. So when we're looking at ratios in like text format, okay, here's just like a quick little example that says in the United States, about 10 out of every 15 people are eligible to vote who are registered to vote. So if we wrote this as a ratio, we could write this as 10 divided by 15, okay, which again will simplify down to 2/3. So again, I can say 10 out of every 15 people, or I could say 2 out of every 3. I could have written that as 10 to 15, which again will simplify down to 2 to 3. So again, I can say that for every 3 people that are registered to vote, only 2 are actually eligible, or I can flat out write that as 10 to 15. And again, I can simplify that and just write that as 2 to 3. So this is how you would see the information in text and the 3 different ways that you could write this. Now, when we start talking terminology, sometimes you're going to see the word rate. And the difference between a ratio and a rate, okay, is a rate is more specific, okay? So a rate is a ratio that is comparing different quantities, okay? And I know that you know of some rates. You probably have heard of something like miles per hour, feet per second. We'll say words per minute. And if you notice, miles and hours are different units. Feet and second are different units. Words and minutes are different units. So these are different ways that you can express 2 different quantities, okay, that have 2 different units. So a rate has 2 different units. That's what you have to kind of keep in mind. To where with a ratio, they can have the same units as well. Like when we were looking at the previous example, we were talking about 10 out of every 15 people. So that's 10 people out of every 15 people. So my units were the same. When we talk about a rate, we have different units. Now, when we talk about a unit rate has a denominator of 1. Okay, so a unit rate might be something where you would say that you're going 35 miles per hour, to where when we look at just a rate, maybe your rate was that you were going 70 miles for every 2 hours. So notice that when I look at 35 miles per hour, I could really rewrite this as 35 miles. The fraction bar usually means per in verbal context. And then I could say 35 miles per 1 hour. So notice that I have a denominator of 1 down here. And I have my miles per hour. So these are rates. And because I have this 1 down here, this is what we have as a unit rate. Now, this 70 miles for every 2 hours, that will reduce down to 35 miles per hour, but as it's written right here, it's just a rate because I do not have a denominator of 1. Once I simplify that and I take it to the next step and I say 35 miles per 1 hour, now I have a unit rate right here. So example 2 is a chart that has different size blizzards from Dairy Queen. You can see we have mini, small, medium, larges, and we have prices here. So for part A, it says find the rate for a mini blizzard. So our rate is going to be, right here is our mini blizzard. So usually we look at dollars per ounce. So my rate then is going to be $2.89 per 6 ounces. Okay, now if I want to do the unit rate, what I'm going to have to do is I'm going to actually have to divide that 2.89 by 6. And when I do that, I get 0.48 or 48 cents per 1 ounce. And you could just write it as $48 per ounce if you want. Okay, or you can put the 1 down there if you'd like as well. And our last example says find each unit rate. For part A, it says that we have 2 liters of spring water, costs $1.98. So typically what we're looking at is finding out how many dollars per liter we have. So I'm going to start out by writing $1.98 for every 2 liters. So this is my rate, but I want the unit rate. So that means I do have to divide it and get 1 on the denominator. And when I divide that, we get 99 cents per 1 liter, or you could just say that that's 99 cents per liter. So you don't have to have the 1, but you need to understand that that 1 is really there. For part B, it says a car goes 425 miles on 12.5 gallons of gas. So typically when we're looking at fuel economy for a vehicle, we want to know how many miles per gallon. So my rate then will be 425 miles for every 12.5 gallons. So I'm going to go ahead and divide that to get my unit rate. And when I divide 425 by 12.5, I end up with 34 miles for every 1 gallon. And again, because this is kind of something that's a little more known, you could write this as 34 miles per gallon, or every once in a while you'll even see MPG, which indicates that it's miles per gallon. Okay, so please let me know if you have any questions. Otherwise, I'll see you guys in class.